Alright, this is part 2 of lesson 10.2, the area of trapezoids, rhombuses, and kites. The area of trapezoids, rhombi, some say, and kites. So let's look at kind of the formulas we've seen before. The area of a trapezoid, 1/2 height, b1 plus b2. The area of a rhombus, 1/2 d1 d2. And the area of a kite, also 1/2 d1 d2. We're going to look at specific examples today, just 3. Not too extensive and pretty straightforward. Okay, so we're going to look at how to find the area of this trapezoid. So again, you need to commit this to memory. The area is 1/2 h b1 plus b2. Okay, so let's see what's given to us. Well, again, b1 plus b2 is the sum of the bases, right? So the sum of the bases. Well, again, to be clear here, the bases, we know they're the bases because they're parallel to each other, right? We know they're parallel to each other. So b1 we can call 8, and b2 is 12. So we know we're going to have 8 plus 12 here. Now again, if we called this top one here, if we called this b2 instead of b1, and we called this b1 instead of b2, it wouldn't matter because then it would just say what? 12 plus 8. Right, which is the same thing as 8 plus 12, thanks to the commutative property of addition. So it doesn't matter which one you call b1, b2. Now, do we know the height? Right? Let's even say that this information was given here. Let's say that we know that this was, I don't know, 5. A lot of students, again, will say that this is the height because it's going up, and it looks close, you know, it's going up, so it looks about how tall it is. That's not what it means. The height and the base, or both bases, the height is always perpendicular to b1. The height is always perpendicular to b2, right? So which one is perpendicular? Well, we see perpendicular mark here. The height is perpendicular to both bases, so the height is 4. Okay, so we have 4 here. We have 1/2, and we have everything we need. So now it's just 1/2 times 4 times the sum of 8 plus 12, which gives us what? Well, 1/2 times 4 is 2, times 8 plus 12 is 20. 2 times 20 is 40. A lot of you are going to stop here and say that's your final answer, which would give you solid partial credit if you have a mean teacher like I am. We don't know what the units are, which means when you're dealing with area, you always need to put units squared or square units. If you do not put that, you do not get full credit. It's very simple. So the answer here would be 40 units squared. So again, that one's pretty straightforward. We'll do some in class together that involve more trig, like if I give you, I don't know, let's think of one for fun. Like if I give you this angle and you need to solve using a trig function for this height, or I give you part of the bases, and you know, there's all sorts of stuff that can be thrown at you, which we'll look at in class. But I just want to make sure you and the viewers know exactly how this formula here, this weird and strange and annoying and headache-worthy formula works. Okay, so it's just about labeling parts and plugging them in. Okay? Now let's move on to example 2. So example 2. Again, you should realize that this is a rhombus. This is a rhombus because all 4 sides are congruent. So it's telling us that this side length here is 2. And it's also telling us that this side length here is 3. Okay, if you're unsure about the labeling. So again, remember now, the area is 1/2 d1 d2. 1/2 the product of my diagonals. Well, we know that a rhombus is a parallelogram, and what can we say about the diagonals of parallelograms? Well, the diagonals of parallelograms bisect each other, right? So the diagonals of parallelograms bisect each other. That's actually, you know, that's obviously not how you spell parallelograms, but shorthand because I'm lazy. So parallelograms, the diagonals of parallelograms bisect each other. So if I know that this red segment is 2, then I also know that this segment here is 2 because they bisect each other. These two must be congruent, right? And I also know that this other diagonal bisects my 2 yellow segments here, right? Which means each of these are congruent as well. And if one of them is 3, then the other one must be 3. So how long is this yellow diagonal? Well, we can call that D1. We say that this is you know, the area is 1/2. D1 would be 6, right? It's this whole thing here. It's this whole thing in yellow, which is 3 plus 3, right? Which is 6. Now, the red one is how long? Well, again, this is 2 and this is 2, which means add these together, you get the whole diagonal, which is 4. Right? So we have 1/2 times 6 times 4. Multiply these together. 1/2 times 6 is 3, and 3 times 4 is 12. Again, because it's area, you need to always put square units or units squared. Okay? If you don't put, that was a terrible box. If you don't put square units / units squared, you will not get full credit. Okay? So that's kind of how that's given to you. The only kind of twist, if you will, that they could give you is they give you one of the side lengths, like something here, which means you need to then use Pythagorean theorem to solve for one of the leg lengths. But that's not too bad. And we'll do one of those in class as well. And if you're not in my class, sorry. You'll survive, hopefully. Last example. We have a kite. We're given this side length of 13. We're given that this part of the diagonal is 5. And we're given this part of the diagonal is... Sorry, I'm at school, so you heard a bell. We're given this part of the diagonal here is 9. So, how do we solve this? We set it up. Again, A equals 1/2 D1 D2, right? And what do we get first? Well, we don't know the full length of this diagonal here, but we do know that this long diagonal here bisects the other one, which means these are, so there should be 3 marks, these are congruent. So this side is 5 here, which means this side is also 5. So now we know one of our diagonals. We know this red diagonal is 5 plus 5, which is 10. So we can say that D1 is 10. Now what about my other diagonal? We don't know this top part here. We don't know what it is. You can use Pythagorean theorem if you want. Hopefully you just recognize that this is a right triangle, right? Because these are perpendicular. It's a right triangle, which means we have a 5, 12, 13. It's a Pythagorean triple. So we know now the top side length. So what's the length of the entire diagonal? Well, it's just 12 plus 9, which is 21, right? Which is 21. So this is 10 times 21. And then don't forget, I forgot the 1/2, right? I forgot the 1/2. Now, what's 1/2? What I recommend here, one of the numbers is odd, one of them is even. So I always recommend multiply the even and the 1/2 first, because that will be easier for you. Okay, multiply the even and 1/2 first. So what's 1/2 times 10? You get 5 times 21, right? And 5 times 21 is 105 square units. Okay? Again, any tricks or anything like that that I could throw in there, I'll show you in class. But that's kind of how the formula is used. I thought that's most important, how the formula is used. Anyway, that should be it. So, you know, have a good day. Typical ending to my videos. Have a fantastic day. And I hope you enjoy Tuesday. Bye, guys.